Hello, welcome to our final presentation. We are group 14. We're going to go over a few things. Our data was from sleep deprivation and cognitive performance. It featured multiple cognitive test results, along with lifestyle and health data about the individuals. There were 14 variables for 60 participants. It is based on a 2024 open source study conducted in the Middle East. Here are our variables, which we're going to go into detail in just a bit. So our first variables were participant ID and sleep hours. The ID is obviously useless, but sleep hours was the number of hours the participant slept to the nearest hundredth. And you can see that it's a pretty large difference between the lowest and the highest for ranging sleep hours from 3 hours to 9 hours. The IQR ranges from about 4 hours to 7 hours. So people are not sleeping as much as they should.
Next, we have sleep quality score and daytime sleepiness. The sleep quality score ranged from 0 to 20, and the daytime sleepiness ranged from 0 to 24 on a questionnaire that each person did. Sleep quality score was fairly right skewed. Daytime sleepiness was fairly uniform, and otherwise, there's nothing crazy of note.
We also measured age and gender in the test. Age is an integer representation from 18 to 43, and gender was almost an even split. There was 62% male and 38% female. And we can see that age was fairly uniform, with most ages being between 35 and 30, or 25 and 30.
Or the data included BMI, which although we didn't have weight and height directly, we could use BMI to estimate it because it's a function of those two values, and we have the value to the hundredth, and it's about normally distributed.
Caffeine intake. There was on a scale of 0 to 5, and it appears to be fairly skewed right, as most of the values reside around 0 to 1, and the box plot is fairly normal. For the variables physical activity and stress level, they're on an integer scale from 0 to 10 and 0 to 40, respectively. Both of them appeared to be skewed right, with the higher values appearing at the lower tails, and both box plots appear fairly normal.
Our fourth cognitive test was task reaction time, which is the reaction time to do the Shroop text, which is to say the code at the front of the word that you are reading. It is seen that it's fastest for if the word is the call, and slowest when the word is another call. And you can see from the histogram that we have higher times than average. The meaning, I mean.
For the NBAC accuracy, this is a test that measures memory by having participants repeat letters. And from the histogram, it appears to have a fairly normal distribution, but some higher values at the higher ends. And the box plot appears to be fairly distributed evenly.
We also measured emotion regulation score. This was how well the participant manages their emotions. It was scored by a questionnaire, higher meaning better regulation. We can see that the regulation score histogram is fairly uniform, with a spike between 30 and 40. It's not quite normal, but it's not too bad. And the box plot supports this.
Lastly, we have psychomotor vigilance task reaction time, which the psychomotor vigilance task, or PVT, is a cognitive task where a participant will look at a string of numbers as starting with 0. As soon as it starts counting up in milliseconds, they will press a button to stop it. Their score is the time between it starts and them stopping. And the PVT reaction time histogram, as you can see to the right, is slightly right skewed. So leading into our general question, all of our models based off of this question. So how do sleep data, health factors, and lifestyle factors affect cognitive performance and emotional regulation in specific cognitive tests?
My question is first, I asked, does gender moderate the relationships between sleep hours, sleep quality, age, and emotional regulation? So our null hypothesis is that all of these interactions are 0, and our alternative hypothesis is that at least one of these interaction effects is non-zero. So you can see the summary statistics for this. The important one that I'll go over currently is the emotion regulation score, which we can see goes from 25 to 54 for the IQR of about 30. But we'll talk about that more later. As for linearity, we can see that the plot is fairly linear for residuals versus fitted, and all of our added variable plots have good cloud shapes. However, the impact is not very high for any of them. Something strange was these lines in the middle for sleep quality score, age, and sleep hours. And for sleep quality score and age, this can be explained because the stuff is measured on an integer scale. So the most common thing is going to be on that specific, and it's not going to go around it at all. For normality of errors, you can see that our QQ plot, the line is hugged fairly tightly for the theoretical quantities, and this is supported by our Shapiro-Wilk p-value, which is 0.3348, meaning that the test is insignificant and we do uphold normality of errors. We also looked at constant variance, and while it has these strange hills and valleys, it is roughly straight. And the Baruch-Pagan p-value of 0.6575 is high enough that we can say that it is insignificant, and we do have constant variance. We also measured outliers and influential points, and nothing exceeds the Cook's distance, so everything looks relatively non-influential, not high leverage values. Final thing we looked at was multicollinearity. We looked at the VIF scores, and this is where we begin to see a problem with gender, and then gender sleep hours, gender sleep quality score, and gender age. Those all had very high VIF values, all up to 28, which is very high. However, it's not as much of an issue once we see why this is happening. We can look at the pairwise correlations, and we can see that everything is very low until we see how they interact with the interaction terms. The interaction terms have very high correlations, up to 0.9. This is because they are interaction terms. So gender sleep hours is going to be dictated by gender because that's how it's created. Same with gender sleep hours and sleep hours. That's why it's higher at 0.4. And we can see these all along have high correlation with the thing that they're derived from. So that is expected. We can see after centering, all of our diagnostic plots look exactly the same, which is also expected. That shouldn't be changing anything. But centering does solve our issue of the high VIF values. That brings it so everything is below that 5 threshold, with our highest being 3, which is fairly normal. After bootstrapping, we begin to see that our test is not going to be significant, as the only confidence interval that does not include 0 is for our first coefficient, which is the intercept. So we can say that the intercept is the only thing that's significant, but that doesn't affect anything because the intercept is when sleep hours is 0, age is 0, and sleep quality is 0. And everything else includes 0 in the intercept, so nothing is confident, even in the bootstrapping case. And this is supported with our cross-validation, which tests the prediction power of the model. And our predictions tend to be off by about 18 or 14 according to the MAE, but this is pretty high since the IQR for the emotion regulation is roughly 30, so that's over half the IQR made with errors in the prediction, which is not good. So we can rule that the results are insignificant. As we can see, the interaction terms for all of these have very, very high p-values. So they are not able to influence how those predictors predict emotional regulation. However, this doesn't go against any of our major preconceptions, since we wouldn't expect gender to moderate how those things affect emotional regulation.
My research question was, how do age, gender, and BMI interact with sleep quality in a model with other lifestyle factors to predict Stroop task reaction time? Here are my summary statistics. If you want to read them, you can pause the video in them. to like save time. My initial model included the interactions I mentioned: caffeine intake, stress level, physical activity level, and sleep hours. On the bottom of the slide is my summary. None of them are statistics, and the R squared is 0.05. Here are my diagnostic plots. Residuals versus fitted is pretty good. So is scale and location. QQ plot goes a little bit off the line on the sides, but overall is pretty good. Cook's distance also is. There are some high distances, but not over the 0.2 minor influence threshold. Here my GVIF, my degrees of freedom modified GVIF values, with the highest being 2.03 for Jindal, and my Buch-Pagan test for variance, which has a high p-value, so implies there's constant variance. My first remedy was to central the continuous values, and then also implied 2-key robust. What you can see from these results is the intercept is now significant, but it still hasn't improved the R squared. My second remedy was to also scale the continuous values and then make another robust model. From these outputs, you can see that the estimates did change because of the scaling, but none of those significance changed. From bootstrapping, I bootstrap all of the 5 models I trained. On the slide, I only include the second Tukey model, which you can see for all predictors and the interactions. For 95% confidence intervals included 0, which further supports the insignificance of the predictors and interactions. For my model selection, I didn't include interactions because they were insignificant, and I also dropped the original and scaled values and just kept the centered ones, because if I kept them all, it would increase to 4 million subsets to have to run through the automatic selection. The 2 models came up from this automatic selection, predicting reaction time with BMI and predicting reaction time with all the variables that were still in. R squared and Mallow CP performed the full model, while adjusted R squared, AIC, BIC, and plus performed the BMI model. I ran 10-fold cross validation. In the RMSE of the BMI model was less than the RMSE model of the full model, which suggests that there's no generalizable benefit from the other predictors. My conclusion is that the null hypothesis cannot be rejected because all the confidence intervals for the interactions contain 0. In fact, all the confidence intervals for all the predictors include 0, and none of the models predicted reaction time well, with the highest R squared for the automatic selection being 0.02, and the highest for the models with interaction 0.05.
So for the next research question, I wanted to analyze how emotional regulation interacts with lifestyle choices such as physical activity level, caffeine intake, and stress level, and how they are able to predict memory accuracy through the NBAC accuracy score. Here are the summary statistics for all the variables. Specifically for NBAC accuracy, the scores range from 50 to 99, demonstrating higher accuracy scores is a worse score. The model summary, we can see that the only predictor that is significant is the intercept, which is at 90 for the NBAC accuracy score. All the other predictors are insignificant at a 0.05 alpha level, indicating that they don't significantly predict NBAC accuracy. For the coefficients, we can see that the intercept is at 90, and all the other coefficients ride roughly along 0, but caffeine intake is at negative 2.717. And seeing the sign reversals, it correlates to the high VIF values, which explains that there is multicollinearity within the data, as they all exceed the 5 and some exceed the 10 threshold, which is severe or concerning. And then along with the pairwise correlations, this is much more interesting as none of the variables appear to have high correlations between each other, but the VIF values indicate that there is multicollinearity between them, explaining the same amount of variance in NBAC accuracy. For the linearity diagnostic, we can see that the residuals versus fitted plot appears fairly normal with no overall pattern in the data. And with the added variable plots, there's no pattern within the individual models, and the lines appear to match a linear model and uphold the linearity assumption. For constant variance, we can see that the Bruce-Pagan test has a p-value of 0.4269, and this is also verified with the plot as there is no apparent pattern indicating that there is constant variance across the whole data. For the normality, we can see that the QQ residuals plot appears to reside along the line for the middle and main part of the data, but the tails tend to deviate further, and this is present in the histogram as it appears to be skewed right, and the Shapiro-Wilk test proves this with a 0.002758 p-value indicating that the normality of errors is not upheld. For outliers and influential points, the residuals versus leverage plot shows no points outside the range of 0.5 Koch's distance, indicating that there are no outliers or high leverage points for this model. The first remedy was ridge regression, which aims to solve the issue of multicollinearity by reducing all the ridge coefficients to closer to 0 through increased number of tests. And from the plot, we can see that the optimal lambda is 54.53659. And from the coefficients, we can see that the intercept decreases to 78, but almost all of the variables are now very close to 0, which is the aim of ridge regression, which presents a CV-MSE value of 182. Now, from bootstrapping, all the coefficients still contain 0 in the interval, indicating that none of them are a significant predictor of NBAC accuracy. The second remedy was Box-Cox transformation, which aims to solve the normality issue. From the diagnostics, we can see that the residual versus splitted plot appears normal with no pattern. The QQ residuals plot looks a lot better as almost all the points reside along the line. The scale location plot demonstrates constant variance as it appears the same as before, and the residuals versus leverage plot also demonstrates that there are no outliers. The Shapiro-Wilk test now increases to 0.4706 p-value, indicating that the normality assumption is upheld and it solved the issue. And the coefficients now are reduced significantly, while also dropping the interactions due to them not being significant predictors of NBAC accuracy. And a lot of the predictors are now very close to 0. And it also solves the issue of multicollinearity as the VIF values are all very close to 1, not being concerning at all. So with regards to model selection, we have the original model, which is the 4 predictors and the interactions, Box-Cox, Model 1 with just caffeine intake, Model 2 with just caffeine intake and physical activity, Model 3 with caffeine intake, physical activity, and emotional regulation. We compare these on the scales of AIC, DIC, R-squared, and R-squared adjusted. And from this, we can see that Box-Cox presented the lowest AIC, BIC, but had the highest R-squared and R-squared adjusted, demonstrating that it's the best model. And within the other 4 models, the triple predictor was the best with the lowest AIC, BIC, and highest R-squared and R-squared adjusted. And for the RMSEs found through cross-validation, the Box-Cox was the lowest of them all, even when presented at a different scale. It is found the lowest from the other predictors. So the conclusion for this model indicates that we reject the null hypothesis. We fail to reject the null hypothesis as the p-values for all the predictors are insignificant, and the 95% confidence intervals contain 0 for all 4 predictors. And when applying the remedies, the Box-Cox transformation was the best. And from the model diagnostics, we can see that it met the appropriate R-squared, lowest BIC, AIC, and CV-MSE, indicating that it was best compared to the other models, but none of the models can accurately predict NBAC accuracy.
Finally, coming to my model, I wanted to look at how does age interact with daytime sleepiness, sleep hours, and sleep quality score to predict attention and vigilance as determined by psychomotor vigilance task reaction times. Here are my summary statistics. The only thing of note is the PVT reaction times ranging from 201.6 to 494.6, which is unusual because the standard for vigilance lapses in the PVT reaction times is all those over 500, so no participant met the vigilance decrement threshold. The full model summary here, you can see that none of the predictors are significant except the intercept, which doesn't really make any sense as an age of 0 or daytime sleepiness, sleep quality score, sleep hours of 0 doesn't make any sense. P-value is extremely high, and the adjusted R-squared is extremely low. For multicollinearity, first looking at those pairwise correlations, they're actually extremely low, which is unusual when you are looking at the VIFs below, which are all over 10. Some of the interaction terms are actually over 20, which results in severe multicollinearity amidst the model. Looking at linearity, you don't see any clear patterns in the residuals versus fitted plot, as well as the added variable plots, although the lines do appear roughly flat. For constant variance, the Breusch-Pagan test was insignificant, and as you can see from the scale location model, there doesn't appear to be anything unusual, and so the data does appear to be homoscedastic. For normality of errors, the Shapiro-Wilk normality test did reach significance, and as you can see from the QQ residuals plot, it does deviate from the line quite a bit at the ends, so the errors are not normal. Outliers and influential points, all of the values were fairly low. Some of them did reach significance, or not significance, but some of them did reach beyond that hat threshold, and but nothing went beyond the Cook's distance threshold. To look at any other relationships within the model, as it did look slightly curved, I did do a polynomial model, but this drastically increased Cook's distance and made things, it did not improve anything at all. So then, because the errors were not normal, I did a Box-Cox transformation, and as you can see from the QQ residuals plot, it does slightly bring them closer to the line, but again, the p-value is far from significance. None of the predictors are significant except the intercept again, but again, not very useful. Then, because there were some outliers and non-normal errors, I did a robust regression. But again, all of the values were insignificant, and the pseudo R-squared value is 0.047, meaning that almost none of the variation in the data was explained by these predictors. So then I centered the predictors to stabilize them with the interaction effects. You can see the adjusted VIF values at the top. Those did drastically decrease, all of them below 5. In fact, none of them above 2. Although, again, none of the predictors reached significance except the intercept. P-value was huge. Adjusted R-squared value was negative and extremely small. So then I did a ridge regression with bootstrap confidence intervals. As you can see from the coefficient trace plot, the optimal lambda was over 15,000. All of the bootstrap confidence intervals did contain 0, which means that none of them were significant predictors. And because I was really annoyed with nothing working, I also did a lasso regression, which basically is very similar to ridge, but it adds the sum of the absolute value of the coefficients to the loss function. But everything was pretty much the same, and nothing reached significance. So using the model diagnostics, R-squared values were all incredibly low. Adjusted R-squared didn't change much, actually made it worse in almost all cases. CP value were fairly standard. AIC, BIC, and PRESS were fairly similar throughout them all, and were all extremely high. So then to deal with any outliers or non-normal sampling, I bootstrapped the original full model, and all of the bootstrap confidence intervals did still contain 0, with the intercept being the only one that didn't. And as you can see from the QQ plot on the right, it did bring things way closer to the line as far as fixing normality of errors. And then I bootstrapped the centered predictors, which basically put things right on the line. It did decrease, or it did shrink the bootstrap confidence intervals quite a bit. And then almost all of them, or some of them contained 0, some of them did not contain 0, but it didn't really do much. So then for cross-validated MSE, first I did it across all of my models, or all of my remedial methods, right? And it might look like Box-Cox and centered interaction, is a lot less, but because they were log transformed, doing that backwards gives you a value very similar to the other ones, although it is slightly better. And then doing it based on adding and subtracting the predictors from the model, you can see that the tenfold CVMSE were all very similar, and none of them really enhance the model to a usable degree. So these are my main discussion points, but to really sum it up quite snappy on the next slide, none of the models or remediated models reach significance. All bootstrapped confidence intervals contain 0, and all CVMSEs were quite large. Thus, we have appropriate evidence in favor of failing to reject the null hypothesis and have evidence in favor that the predictors and their interactions are not significant predictors of PBT reaction time. So an overall summary of all of our models, all models were insignificant even after remedial methods. Some possible reasons are the fact, as I mentioned before, PBT scores were all under 500, so true sleep deprivation was not met, and PBTs are usually used for sleep research, so sleep quality, sleep hours, and daytime sleepiness should have affected PBT scores to some degree.
With that, standard NBAC accuracy is slowly being phased out in the scientific community as it's not as good of a estimator or predictor of memory accuracy, so that could have had an issue with incorporating the different variables and predicting NBAC accuracy.
Another possible reason is that there was little to no documentation for this data. For example, we don't know how daytime sleepiness was tested. We don't know how some of the scales were applied. We don't know the questions and things like that.
One last thing is that the sample size was relatively small, with only 60 individuals. So with a larger sample size, perhaps we could have gotten some significant findings. However, not all of our insignificant findings were going against our preconceptions. As I said with my question, we didn't expect gender to moderate how age, sleep quality, and sleep hours affects emotional regulation. And that is the conclusion that we came to. So even though it was an insignificant effect, it was what we expect and what we were hoping for. Thank you very much.